let's now try to help you understand how the same tree is supposed to work. It's actually, you should really read through the comments over here, which I think is pretty clear, but I'm going to present in a more visual way to give you more intuition. But you should really still read through carefully the comments given to you, and then you should be in a good position to do it. Okay, let's now switch to iPad over here. So let's compare to see if two trees are really of the same structure. So how do we use it? So you can think about this is the root of one tree, this is the root of the other tree. So the way to use it is by doing this. So we would say root number 1, which is a tree node, dot is same tree. And then we say root number 2. We're comparing to see whether these two trees over here rooted at root 1 versus root 2, they are the same tree. Okay, that's what we're doing here. So now the way to do it, the most natural way to do it would be by recursion. Okay, so let me help you think recursively over here. Okay, so the way to do it is, first of all, you should really compare the root. So compare the root over here, they are the same. So that means we should really bother to really compare the left subtree and also the right subtree to see recursively if they are the same. So now you can think about recursively what we should do, since we know the root are already the same contents. So what we should do is go to the left over here. The left should be the same. So here, let me also go to the left over here, right? And now let me highlight it. So now this particular subtree should be the same subtree as this. So you can think about this node dot is same tree, this node over here. Okay, and now we can recursively try to argue. Is this the same? Well, you got to compare the left subtree here and the left subtree here. In this case, it's simply a base case because we are reaching the node where their children are simply just external. In that case, 2 and 2, they are the same. Okay, so now we should really bother to also compare the right subtree over here. And now we can see 6 and 7, they are different already. So you can see, we know that over here. So now this particular subtree and this particular subtree, are they the same tree? No. So we already know it's actually false. So in that case, we shouldn't need to go ahead and compare the right subtree. But I'll just go ahead and do it, and just to show you this, another case where they might be different. In this case, we are lucky that they are actually, structurally speaking, they are really the same. It's just that the contents, they are different. You may have to consider other cases as well. So let's go to the right subtree for the very root over here. So now let's say, let me use a different color over here. Let's say use orange. So now, how do we compare the right subtree over here with this right subtree? So first of all, compare the root. They're the same. So we should really bother to actually go ahead to the left subtree over here. And now you can do it recursively. You'll find that 12, 10, and 12 and 10. Okay, just follow the same recursive procedure as I said. So this part will be okay. But now, if we look at the right subtree over here, so if you look at this particular right subtree and this particular right subtree here, first of all, you can see the root is really the same. So that means we should really bother to check their left subtree. But for the left subtree here, you can see the left subtree is simply external. The left subtree here is external. So that means they are structurally still the same. But now, if you try to compare their right subtree, in this case, it will be the internal nodes 18. But in this case, it will be the external nodes. So you can see they are different. So that means we should also return overall false for this particular orange subtree here. Okay, so now I'm just doing a very quick intuitive sketching about how you should think about the recursion. So that's really something you should have picked up already from the second year. But if you really got trouble, you should really speak to me. Otherwise, hopefully this will be enough illustration for you to get started.